Hello, lovely people. Welcome back to part 3 of this walkthrough for the shadow/predicted paper for the GCSE AQA 2022 higher paper. My goodness, that was a mouthful. Anyway, so back to this question, or question 25. It says complete the table for values for y equals x squared plus x minus 4. Okay, so we're just plotting the graph. So here we go. We've got to complete the table of values. So if x is equal to minus 2, then for this value here, y is going to be minus 2 squared. Wow, that is a bad squared. Minus 2 squared plus minus 2 minus 4. So that's going to be 4 minus 2 minus 4, and that gives us minus 2. Okay, when x is equal to minus 1, we've got that y equals minus 1 squared plus minus 1 minus 4. So that's equal to 1 minus 1 minus 4, which is equal to minus 4. When x is equal to 0, y is equal to minus 4. That one's kind of a bit more straightforward, shall we say. And when x is equal to 1, we've got that y equals 1 squared plus 1 minus 4, which is equal to 1 plus 1 minus 4, which is equal to minus 2. So that's minus 2. Notice the symmetry there. Looks like we're going in the right direction. And then, so we've got x equals 2. So we've got y equals 2 squared plus 2 minus 4, giving us 4 plus 2 minus 4, which is equal to 2. And then when y is equal to 3, we've got 3 squared plus 3 minus 4. So that's 9 plus 3 minus 4. So 9 plus 3 is 12, minus 4 is 8. So we've got the points here. And then it says on the grid for part B, draw the graph of y equals x squared plus x minus 4 for the values of x from minus 2 to 3. Okay, so we've got coordinates. Let's change colors. So we've got a coordinate when minus 2, minus 2, minus 2, yeah, minus 2, minus 2. So when x is equal to minus 2, y is equal to minus 2. Minus 1, minus 4. So minus 1, minus 4. We've got 0, minus 4. We've got 1, minus 2. We've got 2, 2. And we've got 3, 8. So we're going to draw something rough. I'm going to do this maybe with the pencil, I guess. We should be using pencil, shouldn't we? So let's do that with a red pencil just so that you can see. But normally you'd use a black pencil, in your exam. Let's try and do this. So we've got a mark like this. Ideally, it should be a smooth curve, but I'm trying here, guys. I'm trying. Oh dear, wow. Okay, that's like my attempt. Just gonna thicken that. Can I choose a thicker pencil? So, okay, yeah, that's good. That's good there. So it's gonna be like a curve. Ideally a smooth curve. It's not a perfect curve, but that will do. That will do. Okay, next it says, shown is the graph of y equals x squared plus bx plus c. Find the values of b and c. So here we've got a sketch. So the difference between a sketch and plotting is with plotting, you have a table of values and you're plotting those points, and then you're kind of doing it to scale, and then you're doing a rough curve that goes through the points. With sketching, we're using sort of critical points here. So, okay, we've been told that this is the graph of x squared plus bx plus c, and it goes through the points 3, 0, and 8, 0. So basically, we know that when y equals 0, or when x equals 3, y equals 0, and when x equals 8, y equals 0. This brings us back to those factorization days, So we have x minus 3, like this, and we've got x minus 8. Why have I got that? Because if this were equal to 0, our solutions would be x equals 3 and x equals 8. So that is the format of our graph, or of our function. And if I expand this, we get x squared, so that's this, minus 8x that's doing the 8 times minus, the x times minus 8. The 3 times, oh, the minus 3 rather times x is minus 3x. And minus 3 times minus 8 is plus 24. So we've got y equals x squared minus 11x plus 24. Okay, and because it says it's in the form x squared plus something, we know we've got it in the right form. So therefore, we get that b is equal to minus 11 and c is equal to 24. Then that tells us, because it says then find the coordinates of A, so we can see A is the y-intercept, we substitute x equals 0, so y equals 0 squared minus 11 lots of 0 plus 24, which is just equal to 24. So the coordinates are going to be 0, 24. And that is it for this question. Next, shown as part of the curve y equals sine x, write down the coordinates of the point A. So something that we should know about sine x is, of course, it starts at 0, 0. The highest point of the sine graph is 1, and the lowest point is minus 1. And every time it hits the x-axis, so this first point is 0, every time it hits the x-axis, we're adding 180 each time. So this is 180, that's 360. And then this point here is going to be 90, and then this point is going to be 270. So essentially we're going up in multiples of 90 overall. Now to work out the coordinates of the point A, well, that's going to, we can see that's going to be 90 and 1. And it says write down the coordinates of point B. Well, we can see it's at 270 and minus 1. Okay. Next question, complete the table of values for y equals x cubed minus 2x plus 3. So when x equals minus 2, we have that y is equal to, well, that's going to be minus 2 cubed minus 2 lots of minus 2 plus 3. So let's be careful with those negatives. So minus 2 cubed is going to be minus 8. And then we've got plus 4. Then we've got plus 3. And that's going to give us minus 1 overall. Next, I'm just going to change color just so that it doesn't look too similar. And we can see the difference between the different calculations. So when x is equal to minus 1, y is equal to minus 1 cubed. That's minus 1 cubed minus 2 lots of minus 1 plus 3. And that is going to equal minus 1 plus 2 plus 3. And that is going to equal 4. So that's going to be 4. When x is equal to 0, again, that's a bit more of a straightforward case. Y is equal to just 3, because 0 cubed minus 2 times 0 is all 0, and plus 3 is 3. Then we have over here, changing colors again, we have 1. So we have y is equal to 1 cubed minus 2 lots of 1 plus 3. So that's going to be 1 minus 2 plus 3. So 1 plus 3 is 4, minus 2 is equal to 2. Okay, and then next we've got when x is equal to 2. So we end up with y equals 2. Let's change colors actually because, yeah. Y is equal to 2 cubed minus, that's cubed, minus 2 lots of 2 plus 3. So y is equal to 8 minus 4 plus 3. So that's going to be 8 plus 3 is 11. Take away 4 is 7. So that's 7. And then part B, it says we want to draw, or it says to draw the graph of y equals x cubed minus 2x plus 3 for all values of x between minus 2 and 2. So we know that when x equals minus 2, y is equal to minus 1. So that's going to be over here. When x is equal to minus 1, y is equal to 4. That's a big jump. When x is equal to 0, y is equal to 3. When x equals 1, y is equal to 2. Yep. When x is equal to 2, y is equal to 7. So we've got points there, and we join it with a smooth curve. I'm going to draw it again in red. And the idea should be that it's a curve that goes something like this, something along these lines, something along these lines, and then something like that. So that's the approximate shape of a cubic graph, and that is fine. Okay, next we want to match each graph to the correct equation. So it is important that we understand the general look of certain graphs. So this first graph, of course, that's an x squared graph. This next one is exponential, and the only exponential function is 2 to the power of x. Again, to get an idea of these kinds of graphs, it's always good to draw like a little table of values and always think about what happens when x is equal to, say, 0. Pardon me. And then some negative numbers and some positive numbers. So for example, with this one, when x equals 0, y is equal to 1. But when x goes negative, you have 2 to the power of a negative number, which is 1 over 2 to the power of whatever. So it gets smaller, but never actually gets to 0. And then as x gets positive, it grows, it doubles. So it's getting bigger really quickly. Okay, don't know really why I had the arrow there. Next, this is the reciprocal graph. So this is the 1 over x graph. And then this last one is the cubic graph, the x cubed graph. So let's just write that over here. So x cubed is graph D, 2 to the x is graph B, and the 1 over x graph is graph C. Okay, next, draw the graph of y equals 3 to the power of x for values of x from -2 to 2. So we need to plot some points. We need to plot some points and let's go, okay. So they're asking us to do it from -2 to 2. So let's just plot and let's just work out some different values of x. So -2, 1, 0, 1, and 2. So if y is equal to so if x is equal to, let's start from the right hand side actually. If x is equal to 2, y is equal to 3 squared, 3 to the power of 2, which is 9. If x equals 1, then y is equal to 3 to the power of 1, which is just 3. And then as we go left, we're just dividing by 3 each time. So for x is 0, we have y equals 3 to the 0, which is 1. So again, dividing by 3. This should be -1. When x equals -1, we have 3 to the power of -1. So we divide by 3, the 1 by 3 on the right-hand side, which gives us a third. And then for x equals -2, we have 3 to the power of -2. Dividing that by 3, we get 1 over 9. Okay, so we have x equals 2, y is equal to 9. That's 1 point. We have x equals 1, y is equal to 3. That's another point. X equals 0, y is 1. X equals -1, y is equal to a third. This is where it gets a bit awkward because you have to really judge quite well. And the next one, oh my gosh, this is like, ooh, wow. Make sure you just don't touch the x-axis. That is the main thing. Wow, this is kind of mad. Let's see how this is going to work. Whew. Right, so let's try. This is not too bad. Do you know what? This isn't too bad of a curve, I must say. Let's not speak too soon. Yay! Wow. Hey! Okay, that's not too bad, not too bad. And I think practicing these kinds of graphs would be good, and it also helps you get more acquainted with exponential graphs. Okay, next question. Oh, next. Okay, S is a geometric sequence. Let's change, I don't know what color I want. I want red, I think. S is a geometric sequence. The first 3 terms of S are x plus 18, x, and 2x minus 15, where x is positive. So a geometric sequence, just to give an example, would be, say, 1, 4, 16, 64, 256, 1028. So to generate each term, we're multiplying by the same thing. And this time, we're multiplying by 4 each time. So that's just to give you an example of a geometric sequence. So let me just cross that one out because that was just an example. Now, why is that relevant? Well, to get from x plus 18, which is the first term, to x, we have to times by something. And to get from x to 2x minus 15, we have to times by the same something. So in other words, if I take the third term, which is 2x minus 15, and divide it by the second term, which is x, that's going to be the something that we need to times by. But also to get that something, we can get that by doing the second term, which is x, divided by the first term, which is x plus 18. So we've created an equation here, and we're going to solve it. Let's use cross multiplication. So we end up with 2x minus 15, like this, multiplied by x plus 18. So remember the cross multiplying video that I have. If you need to see that, just to see the technique applied a few times, it's Joy-Colombo cross multiplication, or solving equations with cross multiplication. And that is equal to x times x, which is x squared. Now let's expand this left-hand side. So we get 2x times x, rather, which is 2x squared, 2x times 18, which is plus 36x, minus 15 times x, which is equal to minus 15x. And then minus 15 times 18, well, 18 times 10 is 180, 18 times 5 is 90. Add those together, you get 270, so that's minus 270. And that equals x squared. We've got a quadratic. Whenever we're solving any quadratic, what do we do? What do we do? We always make it equal to 0. So if I take away x squared from both sides, I'm left with x squared, because it's 2x squared, take away 1x squared, which is just x squared. And then 36x minus 15x is going to be plus 21x. And then it's minus 270. And then that is equal to 0. Now I can factorize this. I need two numbers that multiply to give minus 270, but add to give 21. That's going to be 30 and minus 9. So I get x plus 30. And then I have x minus 9. And that is equal to 0. So that means that x equals minus 30 or x equals minus 9. Okay. But well, wait. It says find the value of x, so it's only one value of x. And the question also says where x is positive. So we know it cannot be minus 30, so we just say that x equals, oh wait. This should be that x equals 9. This should be that x equals 9. Let me just explain that this line a bit more clearly for people. So I find that answer is x equals 9, but let me explain. So from this factorization, it means that one of the brackets must be equal to 0. So either x plus 30 equals 0 or x minus 9 equals 0. Now, if x plus 30 equals 0, then we get that x equals minus 30. But we know it can't be that because it says x is positive. And then when x minus 9 is equal to 0, that implies that x would be equal to 9, which was indeed the solution that we wanted. Happy days. Next, work out the value of a and b, where we've got this identity. So these three lines means identical. So it means that no matter what values of x we have, these two expressions on the left-hand side and the right-hand side should always be the same. So we need to find the values of a and b such that this works. So let's expand the left-hand side. So I do 9 times 2x, which is 18x. And then 9 times 3, which is plus 27. And then 4 times 2x, which is 8x. And then 4 times b, which is 4b. And that is identical to ax plus 5. Okay. Simplifying the left-hand side, we get 18x plus 8x, which is 26x. 27 plus 4b is just 27 plus 4b. And that is identical to ax plus 5. Now, if these two expressions on the left-hand side and the right-hand side are identical to one another, that means that the x's must be equivalent. So we can say that 26x is equal to ax. Now, the x's can cancel. So we just have 26 is equal to a. And then that means that a is equal to 26. And then the other part that doesn't have x, well, they must also be identical. So the other part that doesn't have x is this. So that's 27 plus 4b. And the part that doesn't have x on the right-hand side is this. So that must equal 5. And if we take away 27 from both sides, we get 4b is equal to 5 minus 27 is minus 22. And then b is equal to minus 22 over 4, which is equal to minus 5.5. So minus 5.5. All right, moving on. The graph shows information about the time taken by 40 children to solve a puzzle. Okay, So this is cumulative frequency, and you always get this kind of S or sigmoidal kind of shape. It says use the graph to find an estimate for the median time taken. So whenever you're doing this kind of question, I'm just going to use the ruler. We always go halfway from the top for median, because median is halfway, it's middle. And we draw a line from the 20, in this case, across to the graph. And then we go down. Oh, well, that was not supposed to happen. And then we go down. So I'm just going to turn my graph over here. And then that takes us down to this point, which 15, 16, 17, 18. So that's going to be 18. So an estimate for the median time is going to be 18 seconds. And it says show that less than 20% of students took longer than 30 seconds. So for those that took longer than 30 seconds, well, we look for where it says 30, and then we draw a graph up to here, which is this number, and then we go across. So that's going to go here, which is this number, which looks like it's going to be like 34. But it doesn't mean the 34 people took less than 30 seconds. We count between 34 and the cumulative. It's that difference. So this gap is 6. So therefore, we know 6 students took longer than 30 seconds. But how many overall? Well, it's 40, so it's 6 out of 40. If we divide both by 2, that is equal to 3 over 20, and timesing top and bottom by 5, we get 15 over 100, which is the same thing as 15%. And we know that 15% is less than 20%. Therefore, we've showed what we wanted to show. In fact, we can put QED, little fancy thing there to say that you've shown what was to be proved, basically. What was to be demonstrated. Quod erat demonstratum, something like that. Anyway, it's Latin. But a nice little posh thing to do at the end when you've proved something. Okay, let's go on to the next question. Let's get rid of this ruler. We've got number 34. There are white chocolate, milk chocolate, and dark chocolate sweets in a bag. A sweet is taken at random from the bag. The table below, or the table shows the probability of getting each type of chocolate. Work out the probability of getting milk chocolate. Okay, that shouldn't be too bad. So all probabilities must add up to 1. So we've got 3 over 20 plus our unknown milk chocolate plus a third, which should all equal 1. Well, if we add the 3 over 20 and the 1 over 3 together, well, times this by 3, times that by 3, this by 20, that by 20, that gives us 9 over 60 plus 20 over 60, and that is equal to 29 over 60. So 29 over 60 plus our something equals 1, which in this case 1 is 60 out of 60. So that means that our missing bit is 31 out of 60. So 31 out of 60, let me just also include that here. Okay, there are less than 500 chocolates in the bag. What is the greatest possible number of chocolates in the bag? Okay. So because we now have the lowest common multiple of the 3 denominators there is 60, that denominator can essentially represent the total number of chocolates. So we need a number that is less than 500. So we need a number less than 500. But also we need a number that is a multiple of 60. Because the idea is you want to be able to have 3/20ths, 31/60ths, and a third. So that means that the multiples of 60 are going to be 60, 120, 180, 240, 300, 360, 420, 480. So this is the biggest number that is less than 500 and is a multiple of 60. So it's going to be 480. Just to check, we are able to work out 3/20ths of 480, 31/60ths, and a third, and they will all be whole numbers. So that is our thing. Okay, let's go to this question, and then we'll conclude this one for this part of the video. So Sally and Laura sit their driving tests. The probability of Sally passing a driving test is 0.7. The probability that both Sally and Laura pass is 0.56. Work out the probability of Laura passing her driving test. So both Sally and Laura basically means that the probability that Sally passes or the intersect, Laura passes, that's going to be the two multiplied. So that's going to be 0.56. So we know Sally is going to be 0.7 times Laura, which is equal to 0.56. Well, from our knowledge that 8 times 7 is 56, we conclude that Laura must equal 0.8. So the probability that Laura passes is 0.8. Now it says complete the tree diagram. Well, for Sally to pass is 0.7, and for her to fail, Sally to fail, that's i.e. not pass, that's 1 minus 0.7, which is 0.3. We know the probability of Laura passing is 0.8, so a little bit more likely than Sally. And the probability that Laura fails is 1 minus 0.8, which is 0.2. And the probability that Laura passes, regardless of Sally passing or failing, is going to be 0.8. And failing is going to be 0.2, so we're good. Then it says, find the probability of both women failing. My gosh, this is like some dark question. Why do you want them to fail? Gosh. Okay. Find the probability that they both fail. So if we want both of them to fail, then we want fail and fail. So I've put and there because the and rule in probability means we multiply. So for Sally to fail, that's 0.3. And means times 0.2. Just again, it's going to be, well, just to show people, 0.3 is the same thing as 3 over 10. 0.2 is the same thing as 2 over 10. So that's equal to 6 over 100. Please don't fall for that trap of writing 0.6. 6 over 100 is 0.06. 0.06. 0.06. Is that the end of that question? That is the end of that question. So thank you guys. I will see you in the next video where we will look at the remainder of this paper, hopefully. Yeah, take care for now.